Hello everybody. In this video let us learn about derivations. To begin with, take this grammar as an example and this input string. Alright. So to get this input string we are using sequence of productions and also we are substituting the value of non-terminal by the terminal. So by this we can understand that E is a non-terminal and ID is a terminal, which is also a token. So for this input string, if we draw a parse tree, so it will be in this way. E produces this minus E, which in turn produces this E in the parenthesis, which is replaced by E plus E, which in turn is replaced by the ID. Right? So this is the parse tree for this input string. So looking into this, we can say derivation is basically a sequence of productions that is applied to get the desired input string. So looking into this parse tree, we can say that a parse tree is a graphical representation of the derivation. Alright, so this parse tree can be constructed in a more precise way by using the derivational view. Alright, so for this production, if you consider where E is minus E, for this production in the derivational concept or in the derivational view, we write it as E derives minus E. The symbol is used in this equal to followed by the arrow mark. So over here the meaning of this form is said to be E derives minus E, which can also be told as E derives minus E in one step. Okay. So while constructing or while using the definition of derivations, we have to concentrate on two things. The first thing is we need to consider which non-terminal has to be replaced to get this input string. Alright. The second thing which we need to concentrate on is which production we have to apply to get this input string. So over here we are using basically this production, right? This first we have used this production followed by this and then this production and finally this terminal is being replaced. Correct? So we have also we should also check which non-terminal has to be replaced first, right? So based on these two concepts or these 2 points, derivation is divided into two types, that is leftmost derivation and rightmost derivation. Okay, to get this parse tree, we can write the derivation to be in this way, correct? E derives minus E in turn derives E in the parenthesis, and which in turn derives or where E also can be replaced by E plus E, and this, okay, concentrate over here, this can also be written as E replaced by my ID plus E. After that the next E is replaced by another ID. Alright, or it can also be written as the same steps followed by minus E, where this E is replaced with ID first, and then this first E is replaced by ID afterwards. So looking into this, we can say that there are two types of derivations, that is leftmost derivation and rightmost derivation. The first derivation, which is there over here we have substituted or we have replaced the non-terminal from the left side, right? The first left non-terminal is being replaced and then followed by the next left non-terminal. Over here the first right non-terminal is being replaced followed by the next right non-terminal. So this is the leftmost derivation and this is the rightmost derivation. So I can write it to be in this way. if it is a leftmost derivation, we write LM below this symbol. Alright, and this one can be written as rightmost derivation. In this way. So this is the difference between rightmost derivation and leftmost derivation. Leftmost derivation, if you observe, we have started to replace the value of non-terminal by from the left side. So it is a kind of top-down parse tree that is being used, and in the rightmost derivation we will be using bottom-up parse tree, which we will learn later. Okay, consider this input string. If I just give this as an input string, so over here I can say that E derives ID. Only one derivation I have used, or there is no need for me to use any of the production to get this input string. So this can be represented by adding the symbol star. Okay, which means E derives ID in 0 or more steps. Okay, in 0 or more steps. Alright, and also if an example, if I take in this way, which yields, which derives, or the derivation we can write it as minus E derives E in turn derives ID. So over here E derives minus ID in one or more steps. So that can be represented by adding the symbol plus above this derivation symbol. Alright, this is the difference between the star and the plus that is being used above the derivation symbol. This represents derivation that is done in 0 or more steps, and this represents derivation that is done in 1 or more steps. So now we have learnt about LM, RM, star and plus. Okay, by using these concepts, let us try to solve few questions. The first one is, we need to consider this context-free grammar and this input string. The first question that is asked is, you have to give a leftmost derivation for the string, for this string. Also the rightmost derivation for this string. Also we need to construct a parse tree, and we should say whether the grammar is ambiguous or unambiguous. Okay, and whatever it is, we need to justify the answer. So let us start to solve one by one. So this is the grammar that is been given, and this is the input string that is also been given. So first we will start with leftmost derivation. Which can be written as, we have to first look into the input string. Okay, so over here also we need to concentrate which non-terminal has to be replaced and which production has to be applied. Okay, leftmost derivation means the substitution or the replacement of the non-terminal starts from the left side, leftmost side. Okay, so looking into this input string, I can write that I have to use this production first, correct? See, over here star is there at last, so I have to use this production, which is derived by using leftmost derivation. So I have written LM over here, S star, and then the next leftmost derivation that is applied is, see, next there is A, and then there is, from the right side I am checking, there is plus. So if we replace this S, leftmost side, right, we have to start substituting it from the leftmost side. So if we replace this S by SS plus, this S has been replaced by SS plus, remaining thing we will write S and then star. Alright, so this in turn derives. See, now that we have got this production, we can substitute it, right? We can substitute S also yields A, right? So we can write, we have to start substituting it from the leftmost side. So this A can be replaced by, this S can be replaced by A. A, S plus S star. This in turn derives A plus S star. This in turn, I'll write it over here, derives A plus A star. See, now we have got this input string. So this is the leftmost derivation for this string. Now the second question is rightmost derivation. To obtain the rightmost derivation, so to begin with, we have to use the same production. Over here we have to write RM below the symbol. Okay, so SS star we will be using. Now we have to start replacing the non-terminal from the right side because it is the rightmost derivation. So looking into this, first let me write this. Over here, what is there next? Over here star we have got for this input string, and then there is A. Okay, and then there is plus starting from the right side. So over here, if you observe, if I substitute the value for S plus first, substitute the value for S at first, then it starts from the rightmost. Derivation starts from the rightmost, right? So I will be writing S A star. I have substituted. Now which is the rightmost thing or the non-terminal that is left? This S, right? So I can substitute now. What else can I substitute this S with? I can substitute it with this production, correct? To get this input string. So I will replace it with SS plus A star, which in turn from the right side, let us start substituting the value for S. Then again the rightmost that is left. Okay, using this rightmost derivation we have got the input string. So this is the rightmost derivation. Next, the third question was to draw a parse tree, to construct a parse tree for this production, for this input string. So let us start with the first starting symbol, that is S, which yields this, which in turn yields this S has been replaced by S plus this in turn is replaced by E. So now we have got A plus A star, right? So check for this. I have drawn for leftmost derivation. For the rightmost derivation, if I start, S is replaced by SS star, then S is replaced by A. I have replaced it with A. Now this S is replaced by SS plus, and then this S is replaced by A, and the next S is replaced by A. So if you observe, there is a same parse tree that can be constructed by using the two types of derivations. For both the derivations, I get the same parse tree. So for a grammar, if we get only one parse tree, if we are able to draw a single parse tree for a given grammar for the given input string, using the grammar for the given input string, that means that grammar is unambiguous. Ambiguous grammar means a type of context-free grammar that produces more than one parse tree. Okay, over here this grammar doesn't produce more than one parse tree, and hence it is unambiguous. Alright, so that was the fourth question that was asked. Correct, right? So we had to tell whether this grammar is ambiguous or unambiguous. So let us take another example over here. We have to consider the context-free grammar as in this way. S has this production plus SS or star. Over here, see, there is a production in this way where plus and star is written after S. Over here it is written before S. And the given input string is plus star A. Alright. So if you observe, this is a postfix expression and this is a infix expression. The question might be asked in this way also. This grammar produces what type of derivation? Okay, question can be asked in this way also. At that time you should tell that this produces infix production expression and this produces postfix expression. Okay, so let us start solving this question. So this is the string, input string that has been given and this is the grammar. So let us write the leftmost, rightmost derivations, parse tree and say whether this grammar is ambiguous or not. The first one is leftmost derivation, right? So let us start with the starting symbol. Over here, observe that A should come at at the end. Okay, so there are 3 A's. Just concentrate on that. And in the beginning, there should be plus. So we have to use this production. Okay, that is the reason we take this production at first. And then this is the leftmost derivation. That also you need to concentrate. Now, from the right side, there is no substitution for terminals, that is token, and then we start with the first non-terminal, okay, from the left side. So this can be replaced by this production. Remaining S we will write as it is. Alright. So now if you observe, we have got these two operators already. Now we have to substitute from the left side. Plus star ESS plus star AAS AAA. See, we have got this input string using leftmost derivation. Alright, now let us write for rightmost derivation. So this is the symbol that is used for rightmost derivation, and then let us start taking the which production we need to take to get this input string. We have to take this production only, correct? And then we have to start replacing it from the right side for rightmost derivation. So if I replace S by star SS, then it will become plus star plus S star SS, using which we cannot get this input string. So what we need to do? We need to substitute the value for S plus S A. If I write in this way, then I can A from the right side I have substituted. The next rightmost non-terminal is S, this S, correct? So for that I will replace by this production. Okay. So this in turn can be replaced from the right side in this way. Finally, in this way, correct? Using which we have got the input string using rightmost derivation. Alright. The third question is we need to construct the parse tree. Let us take for the leftmost derivation first. S is a start symbol using which we derive plus SS. Alright, then this S is replaced, right? So I write star S S. Then I have substituted from the left side A A A. So now we have got plus star A A A. Input string we have got using leftmost derivation. Let us see for rightmost derivation. S plus SS. The next production is this I have substituted. And then this is replaced by star S S. And this in turn is replaced by A. Next this S is replaced by A. So if you observe, we have got this input string plus star A plus star A. So see over here there is only one parse tree, one type of parse tree that can be constructed for this grammar. There is no change over here. That is the reason why this grammar is unambiguous, because it produces only one parse tree. Alright, so in this way we can solve the questions. I hope the concepts are clear for you. We have learnt about what is derivation and the things we need to concentrate for using the derivations, and two types of derivations, that is leftmost derivation and rightmost derivation, and also the meaning of this star and plus. Star means derive in 0 or more steps, and plus means to derive the given input string in 1 or more steps. Alright. Okay then, thanks for watching.